Hi guys. So in this project, we will be building a deep learning model that is to be trained on emotion detection or better yet emotion classification through audio data. We will then prepare our very own website that will be built using the Django framework and hosted on AWS. So let's get started. We're going to move forward with the contents of the project, right? So we're going to go forward with introduction, like an overview of what we are going to do in this project. Then we will talk about the model that we are going to build. Then we will move forward to the Django project, that is creating our website through Django framework, and lastly hosting that on AWS. So the introduction. As I told you, we would be building a deep learning model that is to be trained on emotion dataset to classify which kind of emotion is being portrayed through the audio file, right? We have an extract feature function which is using some other functions from the Librosa library to extract different information about the audio file. We will be using the MLP classifier, which stands for multi-layer perceptron classifier, right? And then we will prepare our very own website using the Django framework and hosted on AWS. So creating the Django project. Now Django is a free and open source web application framework written in Python. It includes advanced functionalities like authentication support, management, admin panels, contact forms, comment boxes, basically any information to be passed from the front end to the back end, file upload system, and much more functionalities, right? In other words, if you were creating a website from scratch, you would need to develop these components by yourself. But by using this framework instead, these components are already built in. You just need to configure them properly to match your site. So basically, the aforementioned functionalities are already present and supported by Django. So you just need to call their classes and create objects, or maybe call those functions and directly use those functions to add on these functionalities, right? And just match wherever you want these functions and to what and where they should perform specific tasks, right? So all of these can be configured in your Django project itself. You don't have to write the code from scratch of creating those functions or classes. Lastly, hosting on AWS. So this is the last stage or step in the process of building the project where we host the newly made website using the Django platform. We will be using the EC2 instance, particularly the T2 micro instance, for hosting the website and understand how exactly the virtual servers and the cloud system works. With this completed, we will be able to access our website and run the model from anywhere across the internet. So let's move forward to the first part, that is building and training our deep learning model. Hi guys. So this is the first part of the project where we will be building and training our neural net model. So we're going to go forward and look throughout the packages that we have imported and see which package corresponds to which functionality and why we have imported them. So Librosa is a Python package for music and audio analysis. And Librosa is basically used when we work with audio data like music generation through LSTMs, or we want to make a speech recognition system. It provides like a lot of building blocks necessary to create the music information, which later can be processed for having a lot of purposes. Like we are moving forward with categorizing what type of emotion it is that is portrayed through the audio file. Some might want to find how rich the sound is in the sound file. So all of this can be processed through the information that can be extracted through functions created inside the Librosa package. Sound file as the next package can read and write sound files only. But the thing is, they have a system of reading, writing, and supports a lot of uh, a lot of types. Like we had .wav, we have MP3, so it is able to support all of them. Now the file reading writing is supported through lib, and its lib sound file, which is spelled as libsndfile, which is a free cross-platform library for reading and writing many different sampled sound file formats. Okay, you don't have to really know what exactly is inside the each package, but you should know why we are using them in this particular project. Then we have the NumPy uh, package, which stands for numerical Python. Now, it is a library consisting of multidimensional array objects and a collection of routines for processing those arrays. Using NumPy, mathematical and logical operations on arrays can be performed. They are performed very efficiently and requires less time for processing too. Right? We have the next package, that is matplotlib, which is a plotting library for Python package, Python programming language, and its numerical mathematics extension to NumPy. It provides APIs for embedding plots into applications using GUI toolkits like Tkinter or GTK. Right. So basically, we can use this library to plot graphs, right? Find key inferences. That is all you need to know. Now we have the sklearn, from which we are calling out our train test split function. We are calling our MLP classifier. We are also calling the accuracy score for gauging how well our MLP classifier that we have trained is performing. So scikit or sklearn is a free machine learning Python library. Okay, it features various algorithms like support vector machines, random forest, k-neighbors, etc. And we will be using the MLP classifier that this library provides. Okay, so that is that, and we're gonna move forward, and later on in this video or probably in the next video we're going to talk about the MLP classifier, how exactly what is happening under the hood basically, right? And if it is a neural network, why are we not using a traditional one instead of this classifier, right? Now, next, okay, before moving forward, there's one thing that you should know about. You have to run this code if you're working with Google Collaboratory, because your Collaboratory is not actually configured to have the access to your drive folders, right? So you have to run this code and give the permissions to the Collaboratory that you can access the particular drive folder and any subfolder or file inside my drive folder. So that is, this first block of code is for that. Now I'm just printing the versions, right? Versions of the packages that I'm using right now. And you might have to install the librosa package, so use the pip3 command to do that, or better yet, you might be having the librosa package if you're working with Google Collaboratory only. Okay, then we have the, okay, so we are creating a function that is gonna take the audio file and extract features from it, right? We can't directly feed the audio file into the classifier, right? Because classifier only takes numerical values as input, right? So, okay, again, talking about the classifier, you might be thinking what MLP classifier is, right? So MLP classifier stands for multi-layer perceptron classifier, which in the name itself connects to a neural network. Okay. Unlike other classification algorithms such as the support vectors or naive-based classifier, MLP classifier relies on an underlying neural network to perform the task of classification. We will dive deeper in the MLP classifier and see what exactly happens under the hood. So let me just open up a board, and in that board let me just showcase you how exactly things are working. Okay, okay, why is this taking so much of time? Anyways, uh, yeah. Okay, so as I talked about the MLP classifier, we have the neural net, right? So I have some layers with me. I have some layers with me. Alright, this is the input layer. This is the output layer. Uh, Please do bear with my writing. It's not the best, I know. So this is the in layer. This is the out layer. These are my hidden layers right here. Okay. So what happens in a traditional model is that you feed your model data here from here. Okay, from left, and you move forward till you reach the output layer, which is on the right hand side, and we have some weights v1, b1, and we have some bias b1 for this layer, and we have some weights here and bias here for this layer, similarly for this one and this one. Okay, so what happens is that we have some weights and bias uh, instantiated whenever a model is created, and you feed in your model, then the output for the first layer becomes the input for the second layer, then the output for the second layer becomes the input for the third layer, and we go on till we reach the output layer. Okay, then what happens is that to see if our model is predicting good or bad, we have the prediction in the output layer, and let's say the prediction y hat was 1. Okay, let's say the classification is for 0 and 1, right? But the actual value for my training set was 0. So the model understands that, oh, I have predicted wrong, right? So we move backwards, which is also known as back propagation. So we move backwards, and what happens here is that we jump to the input, to the hidden layer, then the input layer, and each time we jump, we update the bias and the weights here. Okay, we update the bias and the weights here, so that the model is thinking like, maybe the weights that I had initiated initially were wrong. So let me change my weights and bias, and let's see if again moving forward I would get the correct prediction done or not. So again we are on the input layer right after the back propagation. So we again move forward. That is also known as feed forward. So we again move forward, again reach the output layer, okay, and then we again predict. Now this time, if y hat is again 1, then the model sees that, oh, I'm still predicting wrong, so I need to make changes into my weights and bias. So we again start the back propagation process. Then again we reach the input layer with the updated bias and weights. We again try to predict, and we do that till we actually get our prediction to be 0 only, as it was for the actual value. So this is how our traditional model is working. But in the MLP classifier, we don't have the back propagation process. So we only have the feed forward process. And through this process, the model feeds the data again and again. But the thing is, there's a different method to update the bias and weights. So we're not going with the back propagation. We update the bias in a other method. Now that would, if I start to explain that, it would be a lot more complex to understand. So all you have to know is that we don't have a back propagation here, but we have a different way of updating the weights and bias, and that is how this classifier, right? That is how this classifier is a lot more time saving, is a lot less stressful on the hardware whenever you're trying to, train this model. So that is why we have used the MLP classifier rather than something else or even the traditional networks, right? So that is why we have used the MLP classifier, and now you understand how the MLP classifier is working under the hood. So you can see, okay, coming back to the extract feature. Okay, so this was a function created to extract feature or information from my audio file, which can be used as input to my model so that we can train that on the particular data that we get from the extract feature. Now I would be talking about what features can we extract from the audio files and what are we doing here in the next video. But before ending this one, if you like, you can search about MFCC, what is that? You can search about audio chroma, what is that? And then you can search about mel characteristics of an audio, right? You can search about that because this would make things a lot more easier for you to understand throughout the process of building and training the model. If not, I would be explaining that in the next video too, but that would be in a very brief manner, right? So I'm going to end this video right now and we will move forward with what is happening in the extract feature function throughout the next video. Hi guys, so this is the second part for the first step of the project, right? I'm going to talk about the feature extraction from audio files. So as you can see, we have an extract feature function which is using functions from the sound file, from the Librosa file, right, to extract different kinds of information from my audio file. So let's talk about these particular information. So we have the chroma, right, audio chroma, which pertains to 12 different pitch classes defined for an audio. So what happens is that throughout the audio, if the audio has pitch for a certain class, it would set that it would say that yeah, this pitch is present inside the audio file. So it would send back something like zeros and ones, not exactly that, but yeah, it would tell you what pitch classes are present for this particular uh, audio file. So one main property of chroma feature is that they capture harmonic and melodic characteristics of music while being robust to changes in the timbre or instrumentation used in the particular audio file. Then the next is MFCC. Let's talk about MFCC, right? So as you can see, I'm just taking the sample rate from my sound file dot sample rate. It provides me with the information of sample rate for the particular sound file that we have input, and then and through Librosa STFT, I'm taking my sound file, right, which was read, and then through the sound file I'm uh, getting my values of the chroma back into a NP array, right, that is numpy array, and I'm taking the absolute value. So if I'm getting negative values, I'm removing those and setting them as 0. Okay, uh, either 0 or positive value. Actually it would be positive value only. Then we have MFCC. So MFCC is called a lot of things. Well, they're most frequently, I would say, they're called most frequent considered coefficients, or in the exact terms, it would be Mel frequency cepstral coefficients, which represents the short-term power spectrum of a sound. This is a very geeky thing, and you might not be able to understand from my brief introduction to MFCC. So I would suggest that you go forward and search what MFCC is, what exactly are we taking here, right? So what happens is that there's an envelope of time power spectrum for the audio signal, and it is represented by the vocal tract. So what we are trying to get information about is the vocal tract information from my audio file. So let's say there's some song going on and a person is also singing. So MFCC is going to take information about the person who's singing, and it would then try out to get coefficients. So it creates a expression of some kind, and then it gets the coefficients for that, and it makes a vector from those coefficients and sends back that particular vector, right? So that is what we are getting here. Okay, and yeah, so I'm going to take 40 coefficients for myself and the sample rate that is for the particular file and the file itself, right? Then I have the, okay, so I'm also taking the mean for that. Then I'm inputting that into my results for results array. Then I have the chroma, again the same thing that is happening, and then I have mel. So MEL is MEL spectrogram frequency. So it has a list of frequencies which are regarded in the MEL spectrogram. Again, please do search about it because else you won't be able to understand why we have chosen MEL or MFCC or Chroma for that matter, right? So from the Librosa feature, I'm using the MEL spectrogram to get my values. I'm also taking the transpose for that, okay? And then I'm getting the mean for it. So finally, I return all of my information or extracted information into the results array, okay? Now the data set that we have used is the emotions data set in the RADWES data sets, and it has these many emotions, but we are going to use only half of it, which is calm, happy, fearful, and disgust. Okay, because uh, you need to create a very large and complex model, and you need to have even more features for properly predicting or classifying each and every one of these classes, right? So I've uh, sized down the project so that first you're able to understand what is happening in this project. Then you can improvise, add on other classifications or create even more features for yourself, and then add on other classifications too. So next thing is I'm taking all my audio files so that they can be processed through the extract feature and I can get my values. That is the input data for my model. So you can see that I'm using the glob package and using the glob function where I'm just importing the path. But the path has something, something really cool, because what is happening here is that I have my emotions dataset, which has folders actor underscore one, actor underscore two, actor underscore three till maybe 23, 24. So what is happening here is that I'm telling the glob function that in my emotions dataset, if you find any folder which has actors underscore any number after the underscore, then you have to go inside that function and call out all the files that are present. So you can see that it is going through actor underscore one. It is able to see that, oh, it has a lot of files in it. So call back all of the files. So I have all of the files here. So these are called wildcards. Okay, these are called wildcards, and these are like expressions. If you have used regex expressions, so these are those type of expressions which have some set of rules, and through that rules you can, manipulate and easily get files or subdirectories, move around subdirectories and stuff through the code only. So you can see that there's a list of a lot of music, right? So that is that. Then we have the, yeah, moving forward, now I'm loading the data. So that was just to show you how we're going to access the data. But the next thing is to load the data. Okay, that is to load the data, and you can see I've used the same path and the same wildcard for my glob function. And then what I'm doing is I'm going through each and every file. Let's say I'm going through this particular file, right? So I'm splitting the file on the basis of dash. So it would give me 03, 01, 05 and until 15 point wave. Okay. So I'm taking the two third element from my list, since it is going to return me a list only. So it would the list would have values 03, 0, comma 01, comma 05, comma 01, comma 01, comma 01, comma 15. Okay. So we're taking the third element, which is the 5 right here. So these 5 and 4 and 7, 6, all of these are actually mapped to your emotions right here. Okay. So these are mapped here. So I'm taking the uh, values here and I'm seeing which number is mapped to which emotion. And if that emotion is not inside the subset of the emotions that we created right here, then we can pass on that file. But if it is inside the subset of emotions that we have taken, then you have to send that file into the extract feature function. So we have set all of them as true, so we get all of our features. Then I just append that into my X, which is a list, right? Then we're returning the data in an array format, but here uh, what we are returning is the training and testing data sets, okay, which you can see here. So I've taken 0.25 as my test size, and then you can see that I have uh, I have 576 audio files information in my training data, and here you can see that the the test shape is 192, right? Then we have the feature extracted, so that means that I have 180 columns in my data, and these are the features that we got from the feature extract feature function. Then I've initialized a multi-layer perceptron classifier. So this is alpha, the learning rate, then the batch size, then we have the epsilon, we have the hidden layers. So hidden layer size has a tuple value where each element showcases uh, how many number of neurons are present inside a layer, and the number of elements in the tuple showcases how many layers are present. So in this, only one layer is present. We are using the learning rate as adaptive and max iteration, which is also called epoch, as 500. So after training the model, I get a score of 82.63%, which is good, but we get a prediction score of 71.88% only. Then I have, you can see that the prediction is directly happy, discuss, calm, or right. Then we have plotted the curve, the loss curve for that, and you can see that moving forward to 35, we have reached a very small loss, and maybe moving forward, it had shown even smaller loss, right? So what I've done is I've also created another MLP classifier model, but this time rather than having one layer, I have four layers, right, which have this many numbers of neuron in it, respectively. Then I have also taken the alpha as 0.001, and batch size I've reduced the batch size a little. And you can see that the model on training was giving me 0.94, 94.7% or even 94.8%, but accuracy is still 74.48 only. So here the model was overfitting a little, not little, but yeah, the model was overfitting. But still, we are getting a better accuracy as compared to the before model. And here you can see that the loss was considerably going down till we reached 160th iteration, and then it went constant. So still it is much better than this one, which went constant at 35 when we were moving forward for 500 iterations, right? So this is how we created a model, and the last part is just saving the model. There's no tokenizer here. We're just saving the model, right? So I've used the pickle library and using the dump function to dump the model, and I've given the path where it has to be saved. So with this, we have completed the first step, that was creating and developing and training the model, right? So we're gonna start off with the creation of our website, right, in the next video, and I'm also going to show you how we are going to reload the saved model from here onto our website. So see you in the next video. Hi guys. So from this video onwards, we're going to talk about how to build the website, how we are going to use the Django framework to build the website, and later on through the videos, we're going to talk about how to host the particular Django built website on AWS. Now, what is exactly Django, right? So Django is a free and open source web application framework written in Python. A framework is nothing more than a collection of modules that make development easier. They are grouped together and allows you to create applications or websites from existing source instead of from scratch. Now, I can say that this is how even websites, even simpler ones, right? They are designed by a single person, can still include advanced functionalities like authentication support, the connection of front end and back end, retrieval and storing of data, database management, file upload system, and many more functionalities, right? So in other words, if you were creating the website from scratch, you would need to develop these components which are handling all of the aforementioned functionalities. by yourself, but by using the framework instead, particularly the Django framework. These components are already built in. I will also show you where exactly they are built. And what you have to do is just configure them to properly match the site, or just configure them in a way which you want them to, so that they are functioning and working properly along with your own written code on the Django website. Okay. Now, Django has model template views architectural system that keeps in mind the requirements of the front end and the database management for a developer. We will see what this architecture means and how it makes things easier for a developer. Okay. And moving forward, first let's see how to instantiate a Django project. Now I'm going to give you two scenarios here where you're going to create your own project, right? Or where you're going to use the project that is provided by me, and you just have to configure the project itself. Okay. So moving forward with the first scenario, you have to create a virtual environment, right? So if you're using PyCharm like me, all you have to do is click on File, go to your settings, then there's a pop-up that's going to open, and inside that there's going to be project. So I've created a folder that is emotion classification, inside which I have kept my Django code. Now here inside my project, you just have to click on project interpreter, click on the settings button, then click on add, and in add you can create a new environment or use an existing one. I suggest you create a new one only. Now you can see that I'm getting this thing that environment location directory is not empty. That is because I have already created a environment in onto this path, right? So it is showing me that there's already a virtual environment created there. Either use the existing one or change the location. And you can see that the base interpreter is the Python 7.6, 3.7.6, right? So you can even change that. You can see that I have a lot of other ones too. I have the 3.7 point, okay, that is the same. I have 2.7, I have 3.8.3, I have 3.6, I have 3.10 too. So whichever I want to use, I will go forward with that. But now we are using the 3.7.6 only. Okay. So you will be getting an option of OK here, click on OK. Then it would load some of the existing or required packages like pip. Then once it has done that, you can just click on apply, then OK. So now let's say you were not using PyCharm, so you can go forward with virtual env. You can just create a virtual environment through virtual env and then the name of the env. Then the next thing to do is, once your virtual environment is set up, is to install Django. So you will write a command like pip install Django and the version of the Django. So I'm using 3.2, so you can use that only. Though 3.2 is kind of old school now, we already reached 4, but still 3.2 has all the functionalities that are required, so I'm going to use this one only. Right. So once we have done this also, we can move forward and create our project. As I talked about before, Django provides an existing source, right? So this is what this existing source is. So once you run this command onto your terminal and just type in any name, I have typed my site for the project name. So this folder right here was created for me. Now this folder had another folder inside it which was of the same name, and inside here I get all my files which are used to configure your Django project. Basically, these files that you see here, settings.py, vsgi, asgi, urls, these files are used to set, or I would say these file holds information about how the Django application is going to behave. If it is going to connect to external application, then how it is going to connect, what is the credentials, if there's some credentials to connect to the particular application or not, right? If you have some cache system or not. So all of that type of information, if you're using sockets and creating socket connections or not, all of that is handled through these files, right? So I will also be going forward and telling you how these files have to be configured, right? But before that, you have to install your dependencies uh, and or packages that are required by the code base itself. So you have to run the command in the terminal, right? So you would run pip install -r requirements.txt. Now this command is going to search for requirements.txt file. So run the command inside the my site directory only, or inside the project name only, right? So you can run the command here, and here you can see, just type in dir. So you can see that I have the requirement.txt file inside my site directory. Run the command here then, and it is going to install all the packages and the dependencies for your project. Then the next thing to do is run this particular command, that is python manage.py start app, name of the app. So once you run this, as I had taken the name as polls, so you can see this folder was created. Now there's a difference between a project and a folder, sorry, and an app. And as you can see, I have my configurational files here, but the polls is having a lot of different files in here, right? So the thing is, when we create a project, it is a code base. When we create an app, it is just a subpart of your code base which has additional functionalities built into it. So when we want to create some functionalities for our website, which is not provided by Django, we create our own apps, right? So that is the command for that. Then you have to run the command python manage.py migrate. Okay, you have to run this command, and this command will instantiate all the tables that is required by Django, or maybe if you have created some tables of your own, then it would create those too. Okay, then this is the final command which I will talk about later. So coming to the second sequence of uh, where you have the code already and you just want to set that up. So just create the virtual environment. Then inside the my site directory, run this command pip install -r requirements.txt. Then run this command right here, python manage.py migrate. So it might ask you to run another command, that is make migration. If it does, just run that command first, then run this command again. Okay, and now your code is set up, right? I would be again talking about this later, because this command is used to start a development server on your local machine so that you can see how exactly your site is working, or if it is working properly or not, right? So I would show you what happens when we run this, right, in the next video, when we have completed or gone over our model template views architectural system. Okay, because that is very important, and that becomes the base for the project, so that you understand how the website is working with the help of the models, right, of the views, and finally the templates. Now I'm gonna talk about the settings.py file. As you can see, a lot of variables are created here, right? You can see that. So I'm gonna go over the important ones, which you might need to make changes in so that your website is working as to the requirement. The first thing to know is the secret key, which is again a secret and is a unique key for each of the Django projects created. Now this is important, and this has to be stored separately so that people are not able to access this. Okay. Then we have the debug, which can be turned on as true or false. And if you turn it as true, then any application error that is happening inside Django, the error will be shown on the web page. But if it is turned off, all it would show is an internal error occurred. So it abstracts the information for the user. So when you're working on development mode, you want to see the errors, you can keep this as true. But when you have hosted your site or pushed your code into the production, then you need to turn that as off. Then we have the allowed host. So this is basically IP addresses for for machines that can access and connect to your Django application. Okay, this is the local host. So it tells you that local machine can access the host. Sorry, local machine can access the website or the code base, and then these hold the IP addresses for your virtual machine. Now I'm going to talk about this in a little bit, what we have done here, right? Then we have the installed apps, right? You can see that we already have inbuilt apps provided by Django, which are handling the admin part, which are handling authentication, sessions, right? So you already have these apps, and you can even call out, go inside these particular, these are going to be py files only or apps only, inside where you're going to see different py files having different functions inbuilt them. You can just call them out to use them directly rather than writing code for them from scratch. Then we have listed out the app which we have created so that we are able to uh, implement additional functionalities that Django may not provide. You can even see that Django is handling the middlewares too. There's a security middleware, there's a session middleware, there's a CSRF middleware, which is used for CSRF tokens when we are working with forms in the front end, right? Then we have the templates. So the templates is nothing but anything that is served to the user whenever the user hits a particular URL. Let's say you go to www.google.com. So you see the dashboard, right, which has a search bar. So that is called template. Anything that is served to the user which is responsive is templates. Okay. So if you have instantiated a particularly new project, you would see this as empty. So type in templates here. Then we have the databases. So you can even connect external database, or you can use an existing one, which is SQLite 3, which is given by Django only. If you want to use an external application, you can do so. You can have to add on additional keys, which might be like the user for this particular database, the password for it, right? So, or maybe even the host name or the port where the connection is going to occur. So all of that is stored here. Then we have the cache system. So by default, we can use anything which is specified here. And we are using the low mem cache, which is using the memory cache only. And we type in the name, which should be unique, so that at this unique, let's say, place, which is named unique snowflake, my low mem cache is going to store anything that we have put inside the cache, right? So it should have a unique location. So these are the important bits that you should know about whenever you're setting up your settings.py file for your Django application. So I think I've completed whatever I wanted to in this video, right, about setting up your code base and configuring your code base or the Django application. So in the next part, we're going to talk about the model template views architectural system. I shuffle them up, but they mean the same thing only, that there's a particular architecture that Django follows, and it helps us in creating a website. But before ending this video, let's talk about the .env file. So you can see there's a .env file, and this holds all my sensitive information, which is not so sensitive right now, but yeah. So you can create a .env file, and you can use the load.env function from the .env package to load all of the information from the .env to my system variables. So this load.env sends all of my information from the .env file into my system variables. Then from my system variables, I'm calling out the information through the key name, right? Since we have made a key and the pair, sorry, we have a key and the value. So I call out the key just like I do for dictionaries, and my value is set into the uh, particular variables, right? So this is what I'm doing. So this helps me in keeping my information secret. So what I can do now is I can just directly delete the .env file, and still the code base is going to call out those functions directly from the system. And that is how, even if a person has the access to your code, he or she won't be able to still get the sensitive information from the code itself. So that is how we have set things up for the project, right? So I'm going to stop here right now, okay, and see you in the next video. Hi guys. So in this video, we're going to talk about the model views template architectural system and how exactly it makes things easier for a developer to develop a whole site by himself, right? Now, what you are seeing is the views.py file, right? So this is the views which is present inside the polls. So each app has a specific views. Okay. Then you can see there's models, and then we have our templates, and inside which you can see I have some HTML files with me, right? So the thing is, we work with model views and templates to create the website, and the flow of information is always going through, maybe let's say, models to views or views to models or index to views then to models, like, so things can be shuffled, but all of the information stays at least at one part, right? It can be in views, or it can be at model, or it can be at the front end. So what happens is that we create the front end, then we create functions in the back end, which is the views.py. And when I say front end, that means the templates only. So let's say that, okay, there's no, let's say there's actually the handler function, which is taking a request parameter, right? So any function that is taking request as parameter, that function is specific and has a corresponding HTML file to render, or basically is a map to a particular part of the front end. So whenever I call this function, it is going to return the output of the render function, and the index.html file is going to be rendered and showcased to the user. So this is how we serve our front end part to the user. Okay, so we have to call this function, and this function is going to serve the file to the user. As you can see, this is again taking a request parameter, so it is handling a separate HTML file. But you can see there's no file to be sorry. This function is not taking request as a parameter, so there's no file for this one, right? So these functions were to just transform data and predict. Anyways, so we have the handler and the uploading function. But you can see that though I've created a lot of functions here, we have no function calls for uploading and handler. So both of these functions do not have their calls in this file. So what happens is that we map the calls to certain URLs in the urls.py file. What we do is that we type in the path, that if a user goes to this particular path or URL, then you have to call this function right here. So let's say that the path usually looks like this, or localhost development, right? So if the path is this, if the user goes on this path, then you have to call the handler function. Okay. Then if it goes to home/upload, then you have to call the upload function. So once you go on this path, it will call the handler function. The handler function will then render the index.html page, and that is how the user will be able to see the HTML page on his or her browser. Now let's talk about the models, right? We have talked about the views and the templates. Then let's talk about the models. So as you can see, we create the models inside the models.py file, which is obvious, and there we create a table. So models are nothing but tables only, right? And when we talk about models, we basically talk about database tables. So you can create your tables here. You can even specify what constraints each of the columns may have, right? You can do that here. And you can see there's these are the columns that this table will have. This is the ID, this is the name, then this is the file, and where the file has to be stored. That should be inside the my data folder, right? And then whenever, what was the date when it was uploaded, right? So you can do that. Now, the thing here is to define the name of the object. We were using the emo name, that is the name of the file. And then there's another function, that is delete function. So what happens that when we call delete for a particular ID, on a particular ID, it would delete that ID and its corresponding data from my table. So we have created a delete function for that, right? Now, as we know about the tables also, which is called models in Django, how does this actually connect to the template views architecture system, right? So the thing is, we hit a particular URL, let's say home, it calls the handler function, right? It calls the handler function. Now the handler function returns the index.html or renders the page. The user is able to see the page. Now on that page, the user inputs the data. Then that data is sent back to the backend and is stored in the models, basically in the table. And then through that table, we are calling the input data, right? Through that table, we are calling the input data with the help of this. And now I'm sending my input data to my transform data function. And as you can see now that this function right here takes in the file path, right, which is my input data, takes in the data, calls the file, extracts the feature and sends back the feature into the data variable here, and then I just feed this feature data to my model and predict the class. So this is how we got our template, which is taking the data from the user, setting that data into my models, then my models is sending the data into the views, then the views is taking that data, manipulating or transforming the data to get the results. Then lastly, I return back the results with the help of a dictionary, right, which is also called context. And here you can see that I'm sending back the result as a value for the key response, right? So this is how the template views, models, model views, template models, architecture system is working. Okay, so this is what we have done, and this is how the website is working, and this is exactly how you're able to manage your database through the models. You can make changes here. You can add or remove some of the columns, right? And even, this is how you are able to manage your database. This is how you're able to work with the front end too, with the help of templates, right? Take uh, you can create forms, you can make changes in the front end part and serve that to the user. So as you can see, I have given a URL where if a user clicks, he would be redirected to the upload page. And in the upload page, again, this is just CSS. Then here you can see that I'm creating a form, and this form is now taking some data, but you can see there's no input or there's no input tag here, right? So the thing is, we create a forms.py file which is handled by Django only, right? The cool thing about this is that you just specify which model or which table is to be referenced. Then you tell that from this table which fields are to be filled by the user. So I've taken the emo name and the file. So in the upload.html, using the form.asp, it is going to tell the user that you have to fill the emo name and you have to select some file. And once it has been done by the user, you have to just click the button submit. So once the data is submitted, this form is automatically able to understand that the user has sent me some data. I have to store that data in the model that we have specified here. And then the models understand that, oh, the forms is sending me some data, so I have to generate that data inside my table. So that data is stored in my table. Once the data is stored, the handler function understands that, oh, I can now call out that data, right? And I can now manipulate the data as much as I want inside my function. So this is how your data is also, moving through the templates to the model, back to the views, again back to the templates where you showcase the result. This might be a little hard to digest, or this might not have made things crystal clear. Sorry, this might not have made things clear, right? Uh, so let me just run the final command we left in the last part, which was the run server command. Okay. Uh, yeah. So the thing is, we are not inside the CD directory where the manage.py file is present. Yeah. So this is going to start a development server on your local machine. Okay. So it performs some system checks, as you can see here, and then it would, once it has configured that all of the things are working perfectly, then you can directly run your Django application, and through your browser you can see how exactly is it performing. I can see that there's a page not found right here, right? That is because there's no function specified for this URL. The functions specified are for home and home upload. So if I go on home, then you can see that we have the page served to us. Then you can click on upload file. A new page is now generated. So this is the default name that we have set up. You can just type in anything and choose a file. Now I'm going to choose some files. Okay, in my data set, there's some files. Okay, so I'm going to choose one file, click on open, then I'm going to submit the data. And now you can see that the category for this particular audio file was calm, right? So this is how your Django application is now working, right? So we have completed the building of the website, right? And we can move forward with the last part, which was uploading, or I would say hosting the website, this Django application, onto AWS services, that is particularly EC2 instance. But before ending the video, okay, so I've also created a validation for myself, which is telling me that this blog is working. And then you can see that my data has the shape of 1 comma 180, which means that I'm sending in one row which has 180 columns, right? My features, and that is input into the data. Another thing is that I have created specific files which you might want to use later down the line. Okay, so the files, I'm gonna close these ones. The file is delete object.py. Now this is importing the table, right? And through that, what I'm doing is, if I call this delete info function, then it is going to delete all the objects or all the rows from my table. So why I might want to do this is because right now you might run this project again and again to test if your website is working properly or not. Okay, so you might have a lot of information in your input table. Okay, that is nothing but the model we created. You will have another folder made where all your input of the files will be saved, right? So the thing is, if you directly try to shift this code to a virtual machine on AWS, right, on the EC2 instance, so all of this data would be sent there too, which is not a good practice. So what you can do is you can uncomment this and run the code again, right? Run the run this again, and then it would delete all the data from your table, and then you can directly just delete this. You can just delete this this folder, and then push your data onto your AWS instance, and then you can run the project again. Okay, there. So that is why I've created the delete info and the delete object.py file, because the thing is, once you shift your code to the instance, it would tell you that in your model there are some files already set up, there's some data already there, so it might create problems for you later down the line. So it's better to just remove everything and then push the code to the instance, right? So this was that, and this is just to see if your table has any kind of data in it or not. just to validate. Okay. So with this, we have completed the second part, right? And we will move to the third and the last part, which was hosting the website on AWS platform, right? So see you in the next video. Hi guys. So in this video, we will start off with the process of initiating a VM, setting up the VM, and then move on to other processes like transferring of your code from your local machine to your VM and setting up of the code base inside the VM so that you can run your project on the virtual machine. Now, for hosting the website we have developed, we will be using the AWS services, particularly the EC2 service, Amazon Elastic Cloud, Compute Cloud, which is also the EC2 itself, provides scalable computing capacity in the Amazon cloud or with the help of Amazon Web Services. Using Amazon EC2 eliminates a lot of hardware requirements, right? And this is why the AWS is so popular too. So Amazon provides you with a lot of following features in terms of EC2, which I'm going to talk about. And this is important to know because with the help of the understanding of these features, uh, you will be able to check which instance you want to use, or inside the instance how do you want to configure or set that instance up, right? Because there are a lot of things you have to set inside the instance, though most of them are handled with default values given by AWS only, but you can make changes and set them up in a way that you want it to. Now, the features that I was going to talk about were let's talk about the AMIs, right? So Amazon provides you with pre-configured templates for your instances. Those are known as AMIs, which is Amazon Machine Images, that are packaged bits that you need for your servers to let's say that when we talk about the packaged bits, these are nothing but like the operating systems or the additional softwares that might be installed on the VM, right? So you can host your website or you can run your particular software on the VMs, right? So that is what the package bits are inside the instance, which are also known as machine images, or for specifically on AWS, Amazon Machine Images. Then they provide various configurations of CPU, memory, storage, and networking capacity for your instance, right? So they have categorized the instances in different types of instances, and each type has a specific configuration of CPU, memory, and storage capacities, along with network capacities. Then they provide you with secure login information and ways to log in into your VM from any remote machine securely, right? So that is done through the key pair structure. And this is important because we too will be creating a key pair that would work as a password for our login into the VM through our local machine. Then they have storage volumes for temporary data. They have persistent storage volumes, which uses Amazon EBS volume services, right? So you can store additional things on your disk and just call them out onto your machine if you require so. Again, we're gonna set things up too. There you will also see the EBS volumes. Then sorry, not we, but Amazon provides a firewall that enables you to specify the protocols, ports, and source IP ranges that can reach your instance, right, using security groups. Then they also provide you with IPv4 addresses for cloud computing, right? Again, important things. Now, let's start off with creating an EC2 instance on Amazon. So we have the EC just okay. So this was the dashboard, right? This was the dashboard. Whenever you would log in, you would be redirected here. Then in search bar, just type in EC2, go to EC2, then it would redirect you to the dashboard for instances, right? And it would list out all the instances that you have created and their status along with their information. So for you, there would be no instances here, right? Unless you have created one before. And what you have to do is launch instance. So click on launch instance. Then you have to choose the AMI, that is the Amazon Machine Image. So this is what I was talking about. So they provide you with Linux, they provide you with Mac OS, they provide you with Windows, they provide you with Red Hat, and we're going to use the Ubuntu server, okay? And the Ubuntu server 20.04 LTS to be exact. Then I'm going to use the x86 structure only and click on select. Then it asks you the choose the instant type, right? As I told you, if we have a lot of types and they have different configurations. You can see the T2 Nano has one vCPU with 0.5 gigs of RAM. T2 Micro has one vCPU with 1 gig of RAM. These both are network performance low to moderate. You can see here the performance is moderate, the sizes are different. T2.2x large gives you 8 vCPUs with 32 gigabytes of RAM. Okay, so these are a lot of types you can choose from them. I'm going to move forward with T2 Micro for obvious reasons. Okay, uh, and those obvious reasons are that our code does not require a very high-powered CPU or does not require a lot of RAM to work with. Right, so we're going to go with T2 Micro only. So you can directly go and click the review and launch. But if you want to configure your instance in a very particular manner, then you can go forward with the next, which shows the configuration or instance. Right, it shows you the details if you want to use one or you want to use multiple instances of the same type that we have chosen before. Then we have if we were to use a separate network or a separate subnet or an existingly created network or subnet. If you want to have a DNS host name, right? Then you have the other capacities like creating a new IAM role for this particular instance, right? Or you can even go to the advanced details and see if you want to make some changes here. Again, click on add storage. So the thing is that Amazon provides you with a default value of 8 gigabytes of storage, which uses the general purpose SSD, and you can go up to 30 GB of free size, but after 30 GB you will be asked to pay for the external extra storage. Okay, so you can either click on add new volume, so it would create two disks which are attached to your instance, or you can just increase the size here till 30 if you want to still be in the free region, else you can go as much as you want. Then you can click on ads and stuff like that. It would take you to the ads, configure security groups. Then, okay, this is a little important because here we are typing the rules which the instance is going to follow whenever we would be trying to connect to the instance, or the instance is going to try to connect to any other application, right? So we can set things up, we can add rules, but I won't be doing things from here because it would defeat the purpose of exactly explaining what is security groups and how it is exactly working. Why do we need to configure that, right? So let this be the same too. Then click on review and launch, and then click on launch. So it would ask you to either create a new key pair or use an existing one. So you have to go with create a new pair, right? The key pair type should be RSA only. Type in name, right? Type in the name that you want, and then click on download key pair. Once you have done this, right? Once you have done this, store the key pair file in a place where you can access it and also remember it, because this is exactly the password that would be used whenever we are trying to SSH or whenever we are trying to log in into the VM to access the VM. Okay, so be careful of that. So once you have downloaded the key pair, you would get the launch instance button ready. Just click on launch. I've already created one, right? So, so also once you have created, you would be again redirected to your dashboard only. So I've already created one, which is the motion detection, and you even see that it's running. So it provides you with details of your instance, right? What is the public address, IPv4 address? What's the IPv4 DNS? What's the private IP? What's the private IPv4 address? Right? Which instance type I'm using? What is the VPC ID? What's the subnet ID? Right? Then you can move forward with security. Then you can see that there's a particular group, security group uh, for this particular instance. Yeah. Then we can even go to network, see the storage capacity. We are using the EBS. Optimization is disabled by default, right? And we're using 8 gigs of space. So before moving forward, let's first understand some of the terms that I went through just now, right? So the first thing is to talk about DNS or public DNS. DNS, that is domain name system, is a standard by which names are used on the internet to resort to their corresponding IP addresses. This means that when we say we go to www.example.com on the web, what happens is that the browser starts to search for uh, okay, it starts to search in a tree structure that this example.com is mapped with which IP address, right? So once it gets that IP, it would see that this IP is for this particular server. So it would ask the server that somebody has asked to serve the files for www.example.com, right? So the server will say that, oh, he wants the dashboard file. So it would send the front end files back to the browser, and the browser then shows the file on, on the screen, and the user is able to see the page. So that is how things are working under the hood. So whenever you type in google.com, so the Google server is asked through the IP that you need to serve the page to the user, and the browser then returns back with the pages and then showcases the page to the user. So that is why DNS or having DNS is important. Having public IP address, sorry, having IP addresses are important, right? Then we talk about the inbound and outbound rules, right? Even here you can see that there are inbound rules, then there are outbound rules, right? So what are exactly inbound and outbound rules? Now a security group acts as a virtual firewall for your EC2 instance to control the incoming and outgoing traffic. Okay. The inbound rules control the incoming traffic to your instance, which means that all the incoming connections coming to your EC2 instance from anywhere across the internet is filtered out using the rules, inbound rules. Then for the outbound rules, all the outgoing connections from your EC2 instance to anywhere across the internet is handled through the outbound rules. So we do have to set them up because we don't want an application which is not authorized to connect to your to your virtual machine is able to connect and do stuff on your virtual machine, which is basically how hackers hack. So you set things up, but the other reason why we have to have this inbound rules configured is because our even our application has to access it, has to access the VM. So you need to set things up in the inbound rules. So the thing is, we go into the security groups here, click here, right? And it would give you the options of inbound, outbound rules. Click on edit inbound rule, and then you have to click on add rule. Let it be the same thing, custom TCP. Type in the port, which is 8000, because Django works on connects on 8000 port by default. Then in the source it should be anywhere IPv4. Then you can type in the description that this is for Django, yeah, working with Django, right? And then you need to click on save rules. So I already have one set up for me, so I'm just gonna go with that only, right? But for you, just save the rule. It would be saved. You would be showcase some message. Then go back to your instance. Right now you have your rule set up too, and you have your VM set up too. Right. So I would go to the next term, which is the VPC, that you might have also seen in the details that there was a VPC ID, right? Now, VPC is a virtual private cloud that enables you to launch Amazon Web Services and its resources into a virtual network that Amazon has defined for you. So basically, you can think of a VPC like an apartment where your furniture or items are analogous to databases and instances, right? And the walls of your apartment isolate and protect your, furniture and items from being accessible to other tenants of the apartment. So this is what a VPC is creating. VPC is making walls around your services so that nobody else is able to access that. And it provides an ID because this is specific to a user. And inside your walls, which is the VPC, you have your different applications like the EBS system working, the VM working, maybe you're using S3 buckets or something, or some other services. So all of that are input there. So that is what a VPC is. Right. So I think we have moved forward and covered most of the topics for setting up the VM on the Amazon Web Service Cloud, right? And though we have learned about a lot of stuff here, we have known how to set things up on the cloud, we still haven't transferred our file, right? So for that, before moving forward to that, we would have to download some applications. Okay. The first is Putty. You have to install Putty onto your local machine. So just search Putty, and this is a free SSH telnet client for Windows. So just download this and install this. Then the next application is PuttyGen. Again, just download this and install this, right? And the last application is WinSCP. Okay. So WinSCP is a software that helps us in transferring the files from a local machine to our virtual machine. It again, it too, uses the SSH method where it takes in the key that we created while we were instantiating the VM. So that key is again used as a password, and then once you are able to log in, you can transfer your files from your local machine to your virtual machine. So install all of these applications, right? And I would be using these applications to transfer the file and set up the code inside our virtual machine in the next video.
Hi guys. So this would be the last video, right, for this project, and we're gonna transfer our files from our local machine to our virtual machine and then set up the code there so that we can run the code and have our site hosted on the AWS platform. Now, as I talked about the three softwares before, I hope you have already installed them onto your machine so that we can directly use them now. Right, so the first thing to move forward with is the as the PuttyGen, right, is the PuttyGen software. So just open that up and it gives you the option of either generating a key pair or load an existing one. So we have already created our key pair through Amazon, right? So we have to load one. Okay, and to load, just click on load and browse into your directories where you have your PEM file with you. Actually, the key pair that gets downloaded is of a PEM format .pem. So search for that, right? Uh, okay, actually, you have to keep that as all files. Okay, and then yeah, you can see that I have the PEM file. Okay, this is the this is a different code base. Sorry, I'm gonna go forward with the emotion classification. Yeah, here you can see there's another PEM file, right? Emotion detection. So just uh, take that one. So wherever you have saved your key, just import that here. Then click on save private key. Click on yes and save it in the same directory or keep it somewhere else. Again, you have to keep it somewhere where you can access it and also remember it, right? So type in the name, anything, and see that we are saving it in a ppk format, that is putty private key. And you can also see I've already created one for myself, which is emotion detection private, again a ppk file. So you have to click on save here. Okay, once you have done that, we are over with the key generator. So the next software is the WinSAP. Okay, so open up WinSAP, and in WinSAP you need two main things. Okay, one is your public DNS, so copy that, right? One is your public DNS, so copy that, and then you're gonna, okay, WinSAP is taking time to open, and the other thing WinSAP requires along with your DNS or host name is the PPK file that we have now just created, and it asks for another information, which is the username. So if you're using the Ubuntu AMI, by default the user name is Ubuntu itself. Okay, so yeah, you can see. Okay, anyways, if you're opening this for the first time, then it would create a new session for you, right? So it has opened this, right? So here you can click on the new site. So you type in the host name here. The port should be on 22 only. Type in the username, which is Ubuntu only. Then for password, you click on advanced. Inside advanced, you have, yeah, authentication under SSH. Okay, authentication. Browse your private key file. Browse it and load it into, yeah, load that here. Okay, click on open and click on open, click on login, and it would connect you. Okay, so now you have a on the left side you have the file structure or directory structure for your local machine. On the right side you have the directory structure for your virtual machine, and you can see that I've already imported the code from my local directory to my virtual machine. Now to okay, so this is again the incorrect one. So we have the okay, this is where my code is set up, so I have to just copy paste it here. Okay, so you just have to drag and drop it onto the right side so that you're able to transfer all your files from your local machine to your virtual machine. Click on OK. Okay. Mm. Then it would ask you for permission. If you really want to do this with a particular way, click on yes, and then all of the file transfer will take place. So inside the file system, you can see that I have all my files with me. So even if, let's say that you have to make some changes, you can just double click on it. You can make the changes, right? Control S to save it and close it, and you can see that all the changes that you made is now transferred to your files in the VM also, right? So you can do that. So this is how you can make changes, add on new files. You can even click on this, and if you want to delete this, just click on delete and okay. So it would be deleted from your VM2. Okay, so this is how we are able to transfer our files from our local machine to our virtual machine on AWS, right? So this is how you can do that. Now if you were to change the sensitive data which we had in our env file, you can see there's no env file here, right? So what you can do is you can even go to find files, type in the env, click on start, and it is able to find the .env file in a particular directory. So you can just select it and click on edit. Now you can make changes here and just save it, and yeah, so you can even find the files which are maybe hidden or not, you're not able to find them in the directories. So you can do all of that. So now the process of transferring the files is also completed. So we move on to the last software that we're going to use, that is the putty, and that helps us in setting up the code. How it provides us with a console through which we can configure and set up the project into our virtual machine. So what you have to do is again type in the host name, that is the DNS, or the IP address, it takes both. Then in the SSH, in the authentication, again browse for your private key file, PPK file. and okay, yeah, here you can see I have my file. Click on open. Again, click on open. Then it would ask you to log in as who. If you're using the AMI, which is the Ubuntu AMI, then it's gonna be Ubuntu only. And now you're logged in into your virtual machine, right? So the thing is, as I talked about the pre-configured template, right? So if I were to type in this, so you can see that there's already Python installed, but the twist is that only Python is installed. The pip is not installed, so you can't exactly move forward with uh, downloading and installing the packages, right? Which is the first step when we are trying to configure the code base. So I'm going to talk about some Linux specific commands which would make things easier for you when you're working on setting up the code inside your virtual machine, right? So the first command to know is the pwd command. It tells you onto which directory you are currently in, right? Then we have the ls-a command. This is the ls command with the a flag, which is telling you to list out all the functions, all the uh, directories, subdirectories, all the files inside a particular directory. So in my Ubuntu, right, in my Ubuntu, I have in the Ubuntu folder .bash history, I have the .local file, .ssh, local .local subfolder, .local .ssh subfolder, my site folder, right? These are these in colors are subfolders. Okay. Yeah, I'm confusing things up. Anyways, so with the ls-a, we have the folders and the files listed out. And then the next command, okay, before moving to next commands, there's a sudo command which gives you super user mode, or uh, which gives you administrative rights onto your machine. So basically, let's say that uh, while running ls-a, it is giving me an error that the user is restricted to not run the ls-a command, right? So what do you do? So what you do is you override it, get the super user mode running with the help of sudo. Then you proceed your original command, which was ls-a, with the sudo command, and then you run the command. So you would be able to see that you would be able to see that you're able to run the command, and you can see the difference here. So the .local.ssh was not accessible to me, but as a super user or as a person who has the administrative right, I have these folders too as accessible to me. Then we have another command, that is the command to open up an editor through our console only. So let me cd into the my site. Right now, let's say I have to make some changes in requirement.txt file, right? So what I would write is nano requirements.txt. Now it has opened up an editor for me. Now I can make some changes here. Let's say that I have made some changes here, right? So you have to type in Control X, then it would ask you to save the modified buffer, type in Y, then it would ask you if you want to name the file similar as or same thing as before, or you want to make some changes in the file name. So type in enter if you don't want to make some changes. Now you have made changes in your file through the editor, right, using the nano function. Okay, so we have covered this too. Let's move forward and run a command, that is free.m. Again, the m is the flag, and we are able to see the memory that our VM has, how much of it is being used, and how much of it is free and available. Right. So we have a similar command for disk storage too, that is the df-h. Right. These dash and anything after it are flags, different flags to run your particular command with different functionalities, right? There can be flags which are useful when you want to show the hidden files also and stuff like that, right? So these are for those. These is the main command, these are the flags with them. So you can see that I have 7.7 GB of size for my dev root, from which 3 GB has been filled up and 4.8 is available. And for different disk parts, we have particular sizes and their usage, right? So that is to see if maybe your file or your disk is being filled up or not. If yes, you can maybe go back and add on a particular disk, or maybe increase the size for your is this existing disk, right? Now, since we have covered up all of this, we have another command that is, okay, where it is stored. Okay, it is stored exactly in, yeah. So what I've done is I've just made some steps for myself when I'm moving through that, moving through setting up the code. So this is the command. So this is the command sudo apt get update or sudo apt get installed python 3 pip, right? So okay, so the thing is, as I told you, pip is not installed, right? Pip is not installed, so you have to either install it, or if it is already installed, which is not the case, you have to update the pip. So once you run this command, it will take some time to download the files used for installing pip. Then it would run other commands to install other packages which are required by pip too, right? So once this has been done, it will take some time, and in between it would ask for some permissions too. So just type in y, right? So once you have done this too, now you can move forward with installing all the dependencies for your code, right? So as I told you, the pip installation will take some time for you, and after that has been completed, you would run the pip installer to install whatever there is in the requirements.txt file. Again, it would show me that everything has already been installed, right? But for you, it will start installing all the packages uh, that are specified in the requirement.txt file. Then you have to run the command which is specific to Django, that is python 3 manage.py make migrations. This is to see if you have made some changes in your models or not, right? So the next command to run is migrate. So you can see it has already shown you that okay, where is it? Yeah, it has already shown you that no changes detected, which means that we haven't made any changes to the models. So since no changes were made, we had no migrations to apply. But still, to check if there are, you have to run these particular commands. Then the last one is to start the server, which is run server 0.0.0.0 colon 8000. Okay, so run this. So you might be saying, what is this file 1, file 2, file 3, right? So this was just the for loop which was running in our code to specify if we already have some audio files input through the user from our front end inside the code base or not. So we already have some, but still, so the thing is, you don't have to really look forward to this. The main thing is to look if your site, or to check if your site is working properly or not. So type in your DNS, then type in the port, then type in the path, and you can see that we have our site running. So just to check if our model is also running perfectly or not. So okay, right, so choose a file. I'm gonna choose, okay, why is it asking me to choose from another? So this was for some other project. Now I'm going to choose one of the audio files, click on open, click on submit, and you can see that, okay, again the emotion is calm only. Cool. Anyways, so you can see that the category for the emotion is calm, and our site is running smoothly, and our model is also working smoothly. So with this, we have completed the third part of our project 2, that was hosting the website on AWS, right? So now you can just access your site through this URL from anywhere, from any machine, and you will be able to see the page, and through that you can just run your models to check if it's working perfectly or not. So I think we have completed this project too, and I hope that you liked it.